Good morning, dear students. Welcome to another session of Introduction to Data Structures and Algorithms. So in previous sessions, we started a discussion with respect to arrays, and we looked into a few of the programs pertaining to one-dimensional array, in which we had observed array traversal. And yesterday we had seen how insertion and deletion operation can be performed using the C program. And we discussed even regarding the sorting technique, in which we discussed mainly regarding the bubble sort, and we saw a program pertaining to bubble sorting technique. So these were the discussions what we had yesterday. So in continuation with the previous session, let us move ahead. So the next topic what we have is the searching operations which are performed in the array elements. So what is basically meant by searching in an array elements? So if I want to identify whether a specific element is present in the array or not, in that case, what I do is I have to traverse through the array elements and try to compare with the element whether it is present or not. So we're trying to find a specific element within the array. So in order to do that, we are traversing through the array. Then if the search is successful, that is, if I obtain whether an element is present or not, if I obtain that element, that is, that element is present in the array, then what I do is I return the location, that is the index of the element, or else I'll not be returning anything. So few of the examples of searching techniques are linear search, binary search, and hashing. So these are few methods by which we can go ahead with searching of specific elements within an array. So now in this session, we'll be discussing regarding one simple method, that is the linear search. Now the name itself tells that the search has to go ahead in some linear fashion. So what is this linear implying? Linear is nothing but it implies that you traverse through the elements one by one in a sequential form. So first you start with the first element, you compare it with the element whether it is the element required or not. If not, go to the next element and try to see whether this element matches with the search element. If not, then go further and you continue till you identify or till you reach the end of the array. So this is what you're performing in a linear search. That is, you are traversing through the array in a sequential form. You start with the first element and move with the respect to next element till the search is successful or unsuccessful. So that is what you are looking forward in linear search. So here, as it is mentioned, the start uh, the in a linear search basically starts with the first element and moves towards the end in a step by step fashion. So you start off with the first element. If the search is successful here itself, you stop, or else you continue till you reach the end of the array, or if you find the element. So this is with respect to linear search. So for example, we can observe over here, say array is consisting of 5 elements which are named over here. And if I specify that I have to identify whether element 8 is present or not. So in linear search, what we do is we start off with the first element 22. The index of this one is 0. The element of 22 is compared with 8. They are not equal. So therefore what happens, index is incremented and next element is taken. So 19 is compared with 8. So these two are not equal. So index is incremented, it comes to this element. So 4 is compared with 8. So these are also not equal. Next index is incremented, and here we can see that the element is 8. So 8, these both are equal. So therefore what happens, index of this element is returned. Index of this element is returned. So in this case, the index is 0, 1, 2. The index is 3. 8 is present at the index location 3. So if the element is not present, suppose you are searching for 9, you are searching for 9. So it'll repeat the same procedure. It will come up to this point. 8 is compared with 9. It is not equal. So index is incremented. 10, this is the last element in the array. So 10 is compared with 9. So it is not equal. Therefore, what you do is you identify that the element 9 is not present in the array, or the search is unsuccessful. So this is how the linear search goes on. Now let us look at the parameter which is associated with the program in which we try to search an element in an array. So we'll go back to a program and we'll try to analyze it. Okay. So here we have a program. So let us try to see what this program is actually doing. So here we can observe we have included the headers, and we have declared the function. Now here we can see that an array is declared which is consisting of 5 elements. The size of the array is 5 as it is mentioned, and we are making use of few of the identifiers for some specific purpose. So now in this case we'll observe what is the purpose of flag and what is the purpose of index. So in the program, we'll try to identify that. So next, in this part, you're traversing the array elements and you're just printing the array elements. That is, these elements are being printed. So next, what you're doing is you are asking the user to enter the element which you want to search. So which is stored in what? It is stored in the identifier k, or the variable k. So k holds the element which has to be searched in this array. So that is what we are looking out. So once that is done, we have the array and we have the search element. Now what we have to do is we have to search through the array elements in order to see whether that element is present or not. And in this case, we are implementing the linear search. So again, for that purpose, we can make use of the for loop. So in for loop, what we have first the initialization condition, which is always executed only once when the for loop is executed. So first initialization happens. So I is equal to 0. Then we are checking the condition whether I is less than 5. Why you're doing that? You observe that there are 5 elements in this array. So because of that, you are specifying this condition, that is I less than 5. So this increment will be executed once the for loop gets executed. If the condition satisfies, then it enters. Now here we can see that for is not having a parenthesis. It is not this part is not present in the parenthesis. So what does this imply? This implies that this if statement is the only parameter or the only instruction which is associated with the for loop. So under this if, you have this entire instructions or statements which are present, and for this if, this is the else which is associated. So what does this imply? From this point to this point is entirely the for block. From this if statement to this semicolon is entirely the is referred for the for block. So now for I is less than 5. So initial first this thing is 0. So 0 is less than 5. It is true. If k, what is k? K is the element which you are searching, and what you're doing, whether k and the element which is present at array of I. So that is, in this case, in the first pass, what you're doing, it is I is 0. So you are referring to this parameter. That is, I is 0 means array of 0 is 22. So whether the search element is equal to array of 0, that is the first element of the array. So here I is used to identify the index which is present in the array. So it is used for that purpose. So if this condition is true, that is at the initial step only, I got the search. If this condition is true, what I have to do? So what we do is, once the search is successful, we identify that we have got the element in the array. So we come out of the loop. No need of searching further. If the search is successful, we got to know that the element is present in the array. So therefore we come out of the for loop. That is this loop. If it is not successful, I have to traverse till the end of the element till it is successful. So in between, if it is success, I come out of the loop. So now here what we are doing, we are checking if the search element is equal to the element which is present in the array. So that is, you are checking element by element. So this is the first element. Since index is 0, it is a first element. So therefore what you do, if the search is successful, you use a flag to indicate that the search is successful. You make it equal to 1. So this is helping to do what? It is helping us to identify that search is successful. I have obtained the array element and it is present in the array. So now you have to keep track of where that element is located in the array. So that you are doing with the help of the index variable. So index is initialized with I variable. So this is nothing but this is giving you the index pertaining to the element which is present in the array. So index you are storing, and you are using a break statement over here. What this break statement does is, it breaks out of the immediate loop which is with which it is associated. So here you can see that here only one for loop is there. So when I come across, I have a break statement over here. So if break statement is there, then what happens is, this makes the execution or the program to move its control after the for block. That is, it comes out of the immediate for block. It comes out of the immediate for block, and whatever statement follows, right, that statement starts to get executed. So in this case, if break is encountered, the control goes to this if statement. So this is the case if the search is successful. Now if this condition is not satisfied, you no need to perform anything. So what he has done, he has specified else semicolon. So you are doing nothing. Even if you remove this statement, it will work fine. Even if you remove this part, it will work fine. There is no, it is just to kept here to just identify that nothing is done if this condition fails. If you want, you can remove this statement. So at present, we'll just keep it as it is. So else do nothing. Else do nothing. So again, what you do is you increment I and repeat this entire thing. So you do this either you do this till you get the element which is present in the array for which you are searching, or else if you come to the end of the array. So this is what you are doing. Now if the search is successful, what you have done, you have initialized flag to 1, which is an indication that that the search was successful. So here you can see that initially the flag is initialized to 0. So 0 implies you have started the search. It will be made 1 only when search is successful, or else what happens, flag will be 0. So therefore what you're doing, if flag is equal to 1, that is, you're checking whether the search is successful. If the search is successful, then you print the index location of the element. You print the index location of the element. So what you're doing, search is successful, and then what you're specifying, element person d, that is, which is present in what you had stored it in k, that is the element which has to be searched. Element k or the person d is present at the index location person d. So this one is stored in the index value, that is When flag is set, you are storing the index value over here. So if flag is 0, even when you come out of the for loop, then it implies that search was unsuccessful. Search was unsuccessful. So that is what is specified over here. Okay. So this is what we'll be trying to analyze. So if I just run this program, so let us see. So these are the elements which are present in the array. Okay, these are the elements which are present. Say I want to search 19. So what it is specifying? It is specifying that element 19 is present at the index location 1. So this is the index location. Now, if I want to search for an element which is not present, say 200. So it specifies that the element is not present, that is search is unsuccessful. So if I have to realize it using the turbo C. Okay. So what we'll do is we will try to add watches. I want index A. So flag. So these are few things. So what, and K is storing the value. So I'll not be anyways I'll not be using that. So we'll just try to analyze it. Okay. So array elements will be initialized at the first. So it will be initialized with these values. So all these values have come over here. So now index I and K. Now you can observe that index I, so it is a garbage value 1420. Now if I don't initialize it, and even if you just observe flag, right? Flag is 1432. It might be any value. It might be 1, it might be 0. We don't know. So therefore, what habit we usually follow in coding is we try to initialize the values if it is required. Hmm? We try to initialize those, so that if you're making some logical aspects or logical connections with the variables, we try to overcome those, so that that is not hampered. And another thing is, whenever you are giving names, right, you can since the programs are simple enough, no need to worry about that, but general tendency is you try to give some specific names which will be able to identify the uh, the details regarding the variables what you are using. So now here you can see that flag is 1432. Now once we execute this, what happens is these will remain same. Index, since we are not initializing it. So you can see that I is 1420. So it is a garbage value. So if I directly use something I less than 5, I will not be knowing whether it will be successful or not. That's why you require an initialization in the for loop. So now we continue. So we can observe what happens to I over here when I start with the execution of the for loop. So initially I will be 0 and the condition will be checked. So 0 is less than 5. So it will print the element. So I will be incremented. You can observe I over here. So what happens? I will be incremented and condition is successful. Therefore, print statement is executed. So this will continue till I becomes 5, because 5 is less than 5 is false. 5 is actually equal to 5. So therefore what happens is when I becomes 5, it comes out of the loop. So I becomes 5, it comes out of the for loop. So the elements are being printed. Now since I'm not using a get ch over here, I'm not able to see the screen. So once we use a get ch, right, we'll be able to see what the elements are printed on the screen. Now next what we are doing is we are asking the user to enter the element what we want to search, which will be stored in the variable k. So now what we'll do is we'll search for element. We'll search for element 4. So I'll just check out whether 4 is there or not. Okay, it has come as 18. It is because of the num block which was there. So again, I'll re-execute it. So I'll take 4. So k is equal to 4. Then we scan through the elements in a linear search fashion. So now again, you can observe the I value. I is initialized to 0. First, this statement will be executed and the condition will be checked. And if it is satisfied, it goes inside. Sorry, where is the array element? So now we'll check. So I is equal to 0. K is the element what you are searching through. So I is equal to 0 means array of 0. So array of 0 is what? Array of 0 is 22. So therefore, what happens? This condition fails. So if this condition fails, what happens is else part is executed and there is no statement which is present in the else part. That is, you are doing nothing. So next I is incremented. So I is equal to 1. So 1 is less than 5. Therefore, it enters the loop. So if the search element, that is 4, whether it is equal to array of 1. So what is array of 1? Array of 1 is 19. So array of 1 is 19. So condition is still false. So therefore it will not enter the if statements. So that next what happens is I is incremented again. So I is incremented again. So here we can see that I is incremented. Now we check whether 4 is equal to array of 2. So what is the array of 2 element? Array of 2 element is 4. So therefore this condition is satisfied. So now what happens? The statements within the if block will be executed. So what happens? So now flag will be initialized to 1 because search is successful and index will be assigned with the value of I, because the value 4 is present at index location 2, which is identified by I. So therefore it will be stored over here. Now you can see that now break statement will be executed. When break statement is executed, it comes out of the loop, immediate loop. So why I'm telling immediate loop is, suppose if you have another for loop before this, that is this for is part of another for. So this break statement will come out of the second for which is present over here, but it will start executing the next statements which are associated with the previous for loop. So we can see when we get the examples over there. So when this break statement is executed, you can see that it comes out of the loop. So I is not incremented, nothing, because search is successful. You have executed the break statement. It comes out of this immediate for loop. So, and next what you're doing is you are checking whether the flag is equal to 1 or not. So in this case, you can see that flag is initialized to 1 because the search was successful. So now what we do is we print the details of what is the element you have searched and at what location it is. So that location is identified by the index. So now we are using get ch, so we can hold on to the screen. So here we can observe. So we had entered what? We had entered the element 4 to be searched through the array. The search was successful. Element 4 is present in the index location 2 in the array. So this is pertaining to the search aspect. So now if you want to check out whether if the element is not present, then what happens? So now what I'll do is I'll type around 123. So I'm trying to search the element 123 in the array. So now what I'll do is, so I is initialized to 0. So k is 123. Whether 123 is equal to array of 0, that is it is equal to 22. No. So therefore I will be incremented whether 123 is equal to 19 because the index is 1. So still it is not successful. whether 123 is equal to 4. No, it is also not equal to the next element. It is also not equal to the next element. Now what happens is I is equal to 4 you have searched. So now what happens, I will be incremented. So it will be 5. 5 is less than 5 will be false. Therefore what happens is it comes out of the for loop. So it comes out of the for loop. I is 5. So in this case, flag was not set to 1. So initially you had set it to 0. So it is as it is. It is not changed. So now we check whether flag is equal to 1. So in this case, flag is not equal to 1. Therefore, this if is not satisfying the condition. This condition is false. Therefore, else part will be executed. So in else part, it will print the search is unsuccessful. The search is unsuccessful. So this is associated with search. How do you look out for linear search in C program? So next, this thing we have a representation of the multi-dimensional array in a memory. So here, what we'll do is we'll consider the first simple this thing that is 2-dimensional, and the same concept will be applicable for 3-dimensional, 4-dimensional as you go ahead. So in previous this thing, we discussed regarding 1-dimensional, in which we required only one index element to traverse through the array or to perform any operations. But when we go for multi-dimensional array, what happens is we require multiple index element to access a single element in the array. So here, first of all, what we call as a multi-dimensional array, it is nothing but array of arrays. So why do we call it like that? So here we can observe, say in this case. So here, this is an array which is consisting of say one row. So next again, if I want a second row, right, I can just put another this thing and enter the elements which are present in the second row. So this forms a two-dimensional array. So similarly, if you want to go for three-dimensional, you can continue with the same process. So it is like array of arrays. So for that purpose, we just specify it as array of arrays. And in order to access the elements, we require subscripts. Subscripts is nothing but it is the index what they are talking of. Therefore, we require multiple index parameters or the multiple subscripts which is associated with the array name, which helps us to traverse through the multidimensional array to search, to sort. So all these things. And array, as it's previously also specified, even for multidimensional, what happens is the elements will be stored in consecutive memory locations. It will be stored in consecutive memory locations, but the order in which they are stored is slightly different, because it depends on two parameters, whether it is following a row order or whether the system is following column order. So the order in which they are stored. Suppose I have an array, so which is something of this kind. Now, uh, after the first element, whether 2 will be stored or whether 4 will be stored. So it depends on whether you are following the row order or you are following the column order. So since these also have to be stored in the consecutive memory locations. So the store can be like this. It can be stored as 1, 2, and 4, 5. It can also be stored in this form, 1, 4, 2, 5. So it can be either stored like this or like this. So it depends on whether it is following column order or row order. So we'll observe or we'll discuss regarding what is actually meant by this. One example pertaining to multidimensional array is say two-dimensional array. So in which how many subscripts are required or the indexes, you require two indices or two indexes or two subscripts. So what is the purpose of those? One will be utilized for the row parameter and one will be utilized for the column parameter. So similarly, if you go for three-dimensional, So you have to have three indexes, and using those three indexes, you will be accessing one of the uh, using those you can access the elements which are present in the array. So now let us have a look of what is meant by column order and row order. So it is actually called as column major order and row major order. So now how the array elements are represented in multidimensional, that is in the memory, how they are represented. Now here we are considering an array which is having a 3 by 3 elements. That is, there are totally 9 elements which are present in this. So now how do I look forward for this? So in column major order, what is done is you arrange the elements column by column. You arrange the elements column by column. And in row major order, what you're doing is you arrange the elements of the matrix in a row by row fashion. So what you're doing, first column elements you store in this consecutive memory locations. So after this, you follow with the second column elements. So here all the elements will be coming. So next, you follow with the remaining column elements. So you are selecting a column and those elements are stored in consecutive memory locations. So once these elements are over, you go for the next column. So similarly in row also, you first select the row. So all the row elements will be stored first. And then after that, once all the elements of row 1 are over, you start with elements of row 2. Then you start with elements of row 3 and so on. So in this case, since it is a 3 by 3, that is, it is telling that there are 3 rows and 3 columns. So what you're doing is, this is how the elements which are present in the multidimensional array will be stored in the memory. Now let us see what this 1 1 2 1 actually are. So now whenever we are considering say a 3 by 3 matrix, now what we have, these are the row elements. So this is pertaining to row 1, these elements are pertaining to row 2, these elements are pertaining to row 3. So similarly, when we observe at the column, so these are the column elements. So this is the first column element, this is the second column element, this is the third column element. So once we observe this, so once we have this, so if I look for column major order, so in column major order, what we are doing is we are selecting the column and storing the elements. So here we can observe, so first column elements are selected. So what are the first column elements? So these are the first column elements. So you store the first element in the column, second element in the column, third element in the column. So here you can see that so when you are specifying like A1, 2, this is actually giving you the information row, column. So this one is pertaining to row and this one is pertaining to column. So here you can see that you are storing the element which is present in first row, first column, first row, first column. Next one is second row, first column, second row, first column. And the third element is third row, first column. So that element is stored. So all these three elements are stored. Now in the next memory location, so if the address of this one is say around 6000, and if it is say integer, it consumes around 2 bytes. So what will be the address of this one? It will be 6002. The address of next one will be 6004. So this will be the column 1 elements, and address of next element will be 6006. So what is the element which will be stored over here? So in this, we come to column 2. In this column 2, first element, which is present in row 1 and column 2. So row 1, column 2. So that element will be stored here. Next, row 2, column 2 element will be stored. Row 3, column 3 elements will be stored. So here in column major, you consider the column and store the elements in the sequential form. Next, once this is done, you come to next column and store the elements in sequential form. So this you continue till all the elements are stored. So this is what is happening in column major order. So next we have row major order. So here you consider one row at a time and then store those row elements in the sequential form, that is in consecutive memory locations. Once all the elements are done, you move to the next row and store the elements. So this you perform till all the elements are done. So here you can see that you are considering the row 1 elements. What are the row 1 elements? The first element is element which is present in row 1 column 1. So row 1 column 1. Next one is row 1 column 2, and last element in this row is row 1 column 3. So you are storing it in this form. So this is basically giving you the row and column information. This also is giving you the row and column information. So once all the elements of row 1 are over, you move to row 2. So this is how the data will be stored in the column major order and row major order, and they'll be again stored in the consecutive memory locations. So this is pertaining to representation of multidimensional array in the memory. Now, how do I identify the address of any given element? Now, for 3 by 3, it will be easy for you to identify because you have only 3 columns and 3 rows. So if we ask any of the address of this, you'll be easily able to identify. But if the complexity goes beyond, then we have to try to search out for different. So in this case, what we are doing is we'll be considering row major and column major aspect, and we'll try to see what will be the address of the two-dimensional array element which is present over here. So now I want to identify what is the address of the element which is present at I comma j, that is at row I and column j. So we try to identify the address of this element. So in this case, what we do is we first need to identify the base address, which is identified by B. So here we were specifying that it is say 6,000. So 6,000, which is the address of the first element in the array, will serve as the base address. It will serve as the base address. So next, what is the word size? So word size is integer, say it requires 2 bytes, float requires 4 bytes, or say double requires 8 bytes. So in this way, so that is the word size. That is how much memory space is required to store the data. For one data element, how much memory is required. So you'll be using that word size multiplied with this entire parameter. So in this one, what is n in this case? N is giving you the number of columns. N is giving you the number of columns. And what you're doing is you're considering n is multiplied with I minus the LBR. What is LBR? LBR is the lower bound of row index. So this has to be specified. Lower bound of row index plus J minus lower bound of column index, that is LBC. So this equation you consider when the elements are stored in row major order implementation. Now, when you come down to column major order implementation, right, the same equation holds, just slight change. The address of the element which is present at ith row and jth location will be equal to base address plus the word size, the whole multiplied with this parameter, and in this parameter we have m multiplied with what, where m is what, m specifies the number of rows. M specifies the number of rows multiplied with say j is specifying the column minus lower bond of column plus I minus lower bond of row. So this is the parameter what we'll be looking out for. So this lower bounds have to be specified when you're dealing with these addresses. So now let us look at a problem and try to understand what is happening. So here, when you're dealing with row major order, you have to consider the number of columns and multiply it with I minus LBR. So this is column parameter, and this, if you have to remember, it is the row parameter. So when you're dealing with row and when you're dealing with column major order, right, you consider the number of rows multiplied with this parameter which is associated with the column J minus LBC, lower bound of column. So now let us have a look at a problem associated with this. So in this case, what we have a 10 by 12 matrix, which is implemented using an array of A of 10 and 12. So this gives you the row, this gives you the column information, how many rows and how many columns are there. If the base address of the array is 200, the word size is 2, so which is say 2 bytes, then compute the address of the element which is present at row 4 and column 7. So in this case, what we have I is equal to 4 and j is equal to 7, and we have the base address as 200. We have the base address as 200. So if it is stored in row major order, what is the address? And if it is if the array is stored in column major order, what is the address? And for both, you can assume the lower bound of row and column equal to 1. So what is this specifying? This is specifying that LBC is equal to 1 and the LBR parameter is equal to 1. Now first follow the row major order. So what is the equation? Address of A of I comma j is given by base address plus W multiplied with this entire parameter. Now since we are dealing with row, this is the number of columns what we need to look out. Multiply with the row parameter, that is I minus LBR plus j in j minus LBC. So base address is 200, word size is 2, number of columns is 12. Number of columns is 12. So n is equal to, so in this case m is 10 and n is 12. So 12 multiplied with I is 4. I is 4. 4 minus LBC, LBR is 1 plus 7 minus 1. So here you get the address of that element as 284 if the base address is 200. Now when we look for column major address, right, a column major order of representation, then here what we have, base address plus word size. So since it is column, this will be the number of rows multiplied with the column parameter j minus LBC plus I minus LBR. So it will be, you substitute the values and you get to see that it is 326. So you can see the addresses are not same, so addresses will be different. So when you're following row major order and column major order, so pertaining to this is pertaining to the how representation of the elements is done in the multidimensional array. That is how they are stored in the memory. So now realization of the matrices, that is for two-dimensional arrays. So it can be here, it is just an example what they are representing. So it's a 3 by 4 this thing. So in this case, you have 3 rows and 4 columns. The index, this numbers what they are specified is actually the index. So in whenever you're dealing with indexes, right, either row index or column indexes, the index always starts with 0. So that is one this thing what you have to remember. So the first element what we have, it is like row 0 column 0. Next element what we have is row 1 column 0. Next element what we have is row 2 column 0. So this is pertaining to how it is indexed, how the elements are indexed. So next one, here it will be column 1, column 2 and column 3. So here you can see that how many columns are there. There are total 4 columns, and here we have totally 3 rows. So m of 3 comma 4, that is m of 3 4 is nothing but 3 rows 4 columns. So these are the indexes pertaining to those elements with respect to the indexes what you are using. So in programming, right, when you are dealing with this, we will be starting off with 0. That is, the first element is always indexed with 0, whether it is one dimensional or two dimensional. So index starts off with 0 over there. So here we have a program which actually realizes that. So we'll be discussing this in the next session. Okay. This is all for today. Thank you.